This next section says to solve for x. So when we're solving rational equations, we need a common denominator just like we used in the last section when we added and subtracted. So the least common denominator between a plus 1 and a plus 2 is simply a plus 1 times a plus 2. So unlike getting a common denominator for adding and subtracting, because there's an equal sign, I'm allowed to do something really, really cool. I can multiply both sides by the LCD, which you couldn't do this when you were adding and subtracting because there wasn't an equal sign. So there wasn't a both sides. So if there's no both sides, how you can multiply both sides by the LCD. A lot of times people learn this trick for solving and they're like, oh wait, I can use that on the last section. And you really can't. You have to do the last section exactly as we did it, keep it as a fraction. A fraction plus a fraction is another fraction. So if you have a fraction equal a fraction and we're trying to solve for a variable like x or a, then you don't necessarily have to keep the fractions throughout the whole problem. You can do something like multiply both sides by the LCD, and that's exactly what I'm going to do here. So I'm going to multiply both sides by a plus 1, a plus 2. Now, I highly suggest that you don't be lazy and just try to think you can do this in your head. Write it out on both sides. Then I'm going to divide out the common factor, and I'm left with 5 times a plus 2. On the other side, the a plus 2 factor divides out, and you're left with 4 times a plus 1. Now it's just a simple solve. So we have 5 times a plus 5 times 2, so that's 5a plus 10, equals 4a plus 4. And then I'm going to get all the a's on one side by subtracting 4a. So that's 1a plus 10 equals 4. And then I can subtract 10 from both sides. And that gets me 1a equals negative 6, or really just a equals negative 6. Now, I have to check my work here. The reason I have to check my work is because when you multiply both sides by a variable, sometimes you get an extraneous answer. So I have to check my work. So I'm going to plug in negative 6 every time I see an a. So we have 5 over negative 6 plus 1 is supposedly equal to 4 over negative 6 plus 2. And I don't actually have to work out each side. All I'm checking is to make sure that the denominator is not equal to 0. And negative 6 plus 5, that's not 0. Negative 6 plus 2, that's not 0. So yay, I check out. Okay. If you really wanted to keep going, you could. So this would be 5 over negative 5 is supposedly equal to 4 over negative 4, and that's negative 1 equals negative 1. It does check out. Do you have to do the whole check? No. All you have to do is when you plug it back in, does it make the denominator 0? If it doesn't, then you're good. Okay, on the next problem, looks like we have a factorable denominator on the third fraction. So x squared minus 9 factors in x minus 3x plus 3. So yay, that's very helpful. The reason that's very helpful is because both of those factors already appear in denominators. So the least common denominator is simply x plus 3, x minus 3. So I am going to not be lazy and write that out on every single numerator. I am I'm going to try to squeeze it in here. So x plus 3 times x minus 3 on every single numerator. Don't be lazy, write it out. Okay, so why was that helpful? Well, the x plus 3 divides out and you're left with 4x times x minus 3. On the second fraction, the x minus 3 divides out and you're left with minus 12 times x plus 3. Don't try to distribute that out because you'll probably forget to distribute the negative. On the second one, the third fraction, both the x minus 3 and the x plus 3 divide out and you're just left with negative 16x plus 24. So now I can distribute this and get 4x squared minus 12x. Okay, minus 12x again minus 36 equals negative 16x plus 24. Now I can combine like terms. I get 4x squared minus 24x minus 36 equals negative 16x plus 24. At this point, I can get all of my values on one side of the equal sign by adding their opposite, which gets me 4x squared. Negative 24x plus 16x is negative 8x. And negative 34 minus 24 is negative 60. Okay, and now I have to factor that. Now that looks like a really hard thing to factor. Looks like a hard trinomial. But if you remember back to your factoring skills, the first thing you want to do is factor out a GCF. So the GCF of between 4, 8, and 60 is 4, so I can divide everything by 4. What that does is it turns this very large number problem into a much simpler problem to factor. This is an easy trinomial with x and x in the front to get x squared. I'm looking for two numbers I multiply to 15 and add to 2. That's a 5 and a 3, with a negative on the 5 and a positive on the 3. I set each of those factors equal to 0. I don't have to set the 4 equal to 0 because it doesn't have a variable, so you can't solve for that. So x equals 5 and x equals negative 3 are my two potential answers. I say potential because I have to check. Now, as I reminded you, we are only checking to make sure that the denominator is not 0. So if I'm checking x equals 5, I have 4x over x plus 3. Does 5 plus 3, is that 0? Nope, that's good. Minus 12 over 5 minus 3. Is 5 minus 3 0? Nope, that's good. And then the last one is a factor of 5 plus 3 and 5 minus 3 over the numerator. But again, the denominator is the thing I worry about. 5 plus 3 is 8, 5 minus 3 is 2, 8 times 2 is not 0. So when you plug it in, it's not 0, it's not 0, it's not 0. Yay, I'm good. How about checking x equals negative 3? So on the first one I have 4 times negative 3 over negative 3 plus 3. Is negative 3 plus 3 equal to 0? Uh-oh. It is equal to 0. Is that allowed? Do I even need to finish the rest of the problem? No. If one of them has a denominator that is not 0, that means it's undefined. So what I have to do is I have to come back to my answers and cross off the negative 3. Cancel it out. Okay? So that answer is just 5, not both. But I want to give you credit for knowing that it was negative 3. So just put like a clean X through it. See, you see that you can still see negative 3 underneath it, but because it's marked out, I know it's not the solution that you want to keep for your answer. Okay, so for the next one, we have irrational word problems. It says write what x represents, write and solve an equation, and then use the solution to answer the question. So the sum of a number and its reciprocal is 29/10. Find the number. So when I want to figure out what x represents, x is the thing that you're asked to find or told to find. In this case, it's a directive. Find the number. So x is going to be the number. There's one other thing that we need to know the definition of, the reciprocal. The reciprocal is just 1 over whatever number they're talking about. So in this case, the number, which is x, and its reciprocal, that's going to be 1 over x. And we have to write an equation. So let's go back and read one more time. The sum. The sum means addition of the number, well that was x we said, right? And its reciprocal, so I'm adding x and 1 over x, is, what does is mean? That's equals. Equals 29/10. Okay, right there is my equation, which is going to be close to half my points, which is pretty awesome. So at this point, I need to find the LCD. Just like it did in the last section, between 1x and 10 is going to be 10x. Fortunately, when you're doing the word problems, the solving comes out a little bit easier than some of the other problems you've been given in the past. So this comes out to be 10x times x, that's 10x squared. because the 1 doesn't have anything to cancel out. But on the second one, the second fraction, the x and the x cancel out. And so you're left with plus 10 only. On the third fraction on the other side of the equal sign, it looks like the 10 and the 10 cancel, and we're left with 29x. Because this is quadratic, I need to set one side equal to 0, so I'm going to move the 29x to the other side, which gets 10x squared minus 29x plus 10 equals 0. Then I have to factor that. Let's see, my choices are 1 times 10 and 2 times 5, 1 and 10 and 2 and 5. So let's see, I'm going to just try this here. Let's try 2x and 5x because I usually like to try the two that are closest together. And then 5 and 2. I don't want the 5 to the 5's next to each other or the 2's next to each other because that would mean that there's a GCF. And there isn't a GCF between 10, 29, and 10. So when I multiply across, I'm getting 25 and 4. The positive on the 10 says both signs are the same. Both signs have to be whatever the sign of 29 is in order to add to the negative 29. So that's both negative. And yep, that does work. So this factors into 2x minus 5 and 5x minus 2. I set both of those factors equal to 0. I'm getting 2x equals 5 and x is equal to 5 halves and 2 fifths. Okay, so I have to check my work with the equation. So my equation was x plus 1 over x equals 29 tenths. So there's only one variable in the bottom. If I plug 5 halves into that variable or 2 fifths into that variable, is that going to be 0? Oh, well, no, that's not going to get me 0. And often there isn't a lot of extraneous solutions on these word problems that I have been giving you. So either the number could be 5 halves, and its reciprocal would then be 2 fifths, and it adds to 29 tenths. Or the original number could be 2 fifths, and its reciprocal is 5 halves, and yet they both add to the 29 tenths. So either one of these, okay, so this is like an or. It could either be 5 halves as a number or 2 fifths as a number. Both of them will satisfy this word problem.